It is 6 p.m., so I'm gonna go get ahead and get started. I think right now it's just you, Dustin, on, so hopefully this can be useful to you, and we'll see if other people trickle in. So, welcome to Solar Oregon's How to Go Solar Plus Storage webinar. Today we are going to be going over some of the basics of how solar works, talking about what would make your home right for solar, going over energy storage as a potential addition you can make to your solar system, talking about all the incentives that exist here in Oregon to help finance the solar system, and then how to get started on installing solar on your home. So my name is Grace, and I am a program manager at Solar Oregon. We are a 42-year-old nonprofit that got started in the 70s advocating for solar as the ideal energy source. And we've changed a lot throughout the last 40 years, but we're still focused on education, outreach, and advocacy. And that includes these regular How to Go Solar presentations, as well as a couple of solar tours throughout the year. We just had our Go Zero tour on October 8th and 9th. And coming up this weekend, actually, we have our solar wine and brew tour on October 29th. So if you're interested in learning more about solar, specifically in agricultural settings, and if you just like drinking wine and beer in a beautiful setting, I will share our Eventbrite with you, and you can check that out. We also do a series of Solarize campaigns and like to focus on peer-to-peer education to help create community and educate about solar. So we are a member-based nonprofit, so our work is made possible by our members. If you already are a member, we'd like to thank you so much. If you aren't a member and are interested, here is the link that you can go to donate. I also will post some other links in the chat that will show up throughout the presentation. So you also can follow us on social media and Eventbrite at Solar Oregon to keep up to date with our events coming up and other presentations like this one. We'd like to give a huge shout out to Energy Trust of Oregon. They are an independent nonprofit that provides resources to help all sorts of stakeholders make their energy use more efficient and affordable. They serve the clients of major utilities, including PGE, Pacific Power, Northwest Natural, Cascade Natural Gas, and Avista. And they provide a lot of support to Solar Oregon, including supporting this workshop today. So huge thanks to Energy Trust of Oregon. We want you to walk away from this presentation with all of your solar questions answered. We encourage you to put your questions in the Q&A feature, and you can find that on the panel at the bottom of your screen. And this helps me. I'm used to doing this with my coworker, Zach, but this helps me look at your questions all together at the end and go through them. But you can still use the Q&A for communications with other attendees and that sort of thing. So before we get started on the main content of this presentation, I'm going to launch a few polls. We request that you fill them out quickly. They really help us get to know who's coming to these presentations and make sure that we're reaching everyone. So the first one is asking about where you are coming from. While I have that poll open, Dustin, I see your question about if we have any programs that involve schools. So I'm fairly new at Solar Oregon. I know that Zach has done some presentations at schools beforehand. He's done one presentation on careers in solar and for students graduating high school. And so that's a presentation we've done in the past. We also have worked with middle schoolers through SAGE and done some kind of green fairs where we show off solar panels to middle schoolers and get them excited about clean technology. So yeah, if you're involved in a school and are interested in that, you can reach out to me. I'll have my email at the bottom at the end of the presentation. I think I just posted in the chat with those links as well. Yes, I did. Great. So yeah, email me if you're interested. Great. Thank you for filling out that poll. It looks most of you are from Portland and one person from Willamette Valley. So welcome. The next poll is asking about demographics. Great. Thank you all for filling that out. And finally, we have one more poll that's asking about your familiarity with some of the programs we'll be talking about today. Great. So it looks like most of you are not familiar or may not be familiar with these programs. So I look forward to teaching you all about them. And with that, I will get back to the presentation. So first, how does solar in general work? So this is a diagram of a solar system, and it's actually quite simple. So here we have the photovoltaic panel or the PV panel, and that's what you most likely think of first when you think of solar. It's not floating in the air here. It's either roof mounted or ground mounted. And this panel is what takes the energy from the sun and converts it into DC electricity. Now, your house electrical panel and the utility grid use AC electricity. So before that electricity can be used, it must pass through what's called an inverter or a microinverter, and that transforms the DC electricity into AC electricity that can then be used by your home electrical panel or by the grid. So if you don't have solar, you most likely have a one-directional utility meter, which has electricity flow from the utility grid through the meter and into your home. Once you install solar, you'll also receive a bidirectional utility meter, and this allows you to export excess electricity you're producing into the grid. And also, if you aren't producing enough electricity from your solar panels, you can still draw electricity from the grid to make sure you always have enough power for your home. So there are two main types of inverters. The first is a more standard inverter that's usually installed next to the home's electrical panel. The second is a microinverter, and these are smaller and installed underneath each solar panel. Both of these types of inverters do essentially the same thing. There are some minor pros and cons depending on your specific setup, and your solar contractor can help you decide which type of inverter is best for you. There also are two main ways to mount solar panels. The first is a roof mount. This is more typical, especially in dense urban environments. Because it takes up less space, you can put it on your roof. The second type of mounting is a ground mount. And the advantage of this is you don't have to worry about your roof quality before installing it. It does take more space. It's more typical in rural environments where you have that space, and it can add an additional cost. This is because you must run a copper wire from the ground mounted solar panel into your home. And that copper wire itself is quite expensive, and trenching it into the ground adds additional labor costs. So that's just something to keep in mind. Net metering is a really great tool that we have here in Oregon. It allows you to utilize the electricity, the savings from the electricity you produce from your solar panels throughout the entire year. What I mean by this is, so looking at these graphs, the orange bar is the electricity you're producing using your solar panels, and the blue bar is the electricity you are consuming from the grid. So during the summer months, you're going to be producing more energy or electricity than you are consuming from the grid. And this excess electricity gets transported onto the grid and you receive net metering credits. Then during the winter months, when you're producing less electricity than you are consuming from the grid, you can use those net metering credits to offset the cost of the electricity you are buying from the grid. This doesn't carry over year to year, but it does, the year does start in March. And this is so that you have all of the sunny summer months up front, so you can gain all those credits and then hopefully use all the credits during the winter months and not have any excess that doesn't carry over into the next year. A huge perk of installing solar is that it can significantly or completely reduce your energy bill. So if you have enough roof space, you could potentially cover 100% of your energy costs. You still might pay, give or take, $11 or $12 a month for interconnection fees, but other than that, you wouldn't be paying anything for electricity. So not every home is perfect for solar, and so we want to go over how to know if yours is. The first thing you want to think about if you want to install solar is your system size. Now, this should mainly be based off how much electricity you consume. This is because, as I spoke about previously, net metering credits carry over month to month, but they don't carry over year to year. So if you accrue a lot of credits during the summer months, but can't use those during the winter months and are left with excess, those don't carry over into the next year and you won't see cost savings from them. So you want to talk with your solar contractor to come up with a system size that meets your average electricity consumption. Other factors you should consider are available space, your budget, and the aesthetics of placing solar on your home. Should be noted that solar system sizes are measured in kilowatts, and the average residential system is around 6 kilowatts. And this is around 18 to 20 panels. However, system sizes can vary widely and can be anywhere between 6 and 35 panels is still common. So once you've determined what your ideal system size is, you can start looking if your home is right for solar. So the first thing to look at is solar axis. This is a diagram of the path the sun takes throughout the year. So here we have the summer solstice and a line for the winter solstice. And as you can see, these arcs are tilted towards the south. So a south-facing roof is going to receive the most sun resource throughout the year. East and west-facing roofs also are typically viable. North-facing roofs aren't recommended because, especially during those winter months, you really won't be seeing much sun on those roofs. Shade is also a huge consideration, especially where we are in Portland in the Willamette Valley. There are lots of trees. And so if your roof is significantly shaded by trees, that might be a limiting factor in installing solar. However, this can be really difficult to self-assess. So we recommend that you talk to a solar contractor who will assess this for you. You also want to think about roof complexity. On the left, we have a more complex roof with multiple different faces and different orientations. On the right, we have a simple roof with just 2 faces in a very simple orientation. So the simple roof is ideal because it allows for a solar system to be installed continuously. A complex roof can work. It just might introduce additional installation costs due to having to break apart the solar system and install it in separate locations, which can add additional materials and labor costs. You also want to think about your roof condition or age. This is an important factor because when you re-roof, you will need to take off your solar panels and then reinstall them, which can add quite a significant cost. Because metal roofs last for a long time, sometimes upwards of 50 years, this is not a big concern for metal roofs. With asphalt shingle roofs, the newer is better. Energy trust incentives, which I will talk about a bit more later, require that you have at least 10 years of roof life. But again, the newer is the better. So we recommend if you have an old roof to wait until after you re-roof to install solar. And this will ensure that you have the longest lifespan of your solar panels as possible. Finally, what's underneath your roof may also affect your solar potential. Your roof must be strong enough, not because the solar panels are heavy, but because they increase the wind shear acting on your roof. Newer homes typically have pre-engineered trusses shown on the left. These cross beams are effective reinforcements and are more than efficient to support a solar system. Older homes and some newer ones may have rafters, which are single beams extending under the entire height of the roof from eave to ridge. Rafters may also be sufficient for solar unless they span too far of a distance outwards. So if you have rafters that do not lie within conservative span limits, some jurisdictions, specifically PDX, may require that you pay an engineer to analyze the strength of your roof. Solar contractors commonly provide this as a service, so it can be incorporated with the rest of your quote. If the engineer determines that your roof is not strong enough, you may have to add reinforcement. Most solar contractors can also add reinforcement for you. So we want to note that even if your roof doesn't meet permitting codes, your roof is likely still fine for solar, and it doesn't necessarily reflect a structural issue with your roof. These permitting codes just tend to be quite strict, especially in Portland. So everything I've described so far is just talking about solar, but I also want to talk a bit about storage. Storage is important because it provides energy resilience. So in this picture, it's an example of a grid blackout where all of the buildings connected to the grid lose power, except for the building that has both solar and storage is able to keep their lights on. So that's the main benefit of a solar plus storage system, is that even if the grid shuts down, you still have some capacity to keep power running in your home. Energy resilience is becoming more and more important. The most common cause of grid shutoffs are storms and squirrels. Other forms are becoming more common, such as public safety power shutoffs. And this is when a utility intentionally turns off the grid in order to reduce the risk of wildfire. There's also some risk of cyber attacks, shutting off the grid. This hasn't happened yet, but it is a possibility. And then finally, the Cascadia seismic hazard or the Cascadia zone earthquake is estimated to shut the grid down in Portland for up to 6 weeks and even longer outside of Portland. So that is something in the future that it could be really beneficial to have extra energy resilience. When I'm talking about solar plus storage, I'm talking about solar, either roof mounted or ground mounted, and then batteries in your garage or shed or somewhere in your home. There are many different brands and types of batteries. We are a brand agnostic nonprofit, so we can't recommend any one of them. But you can talk to your solar contractor and they often will have recommendations and can help you talk through which one might be best for you. If you're interested in solar plus storage, you can either go for a partial home backup or a whole home backup. A single battery will only back up part of your home, and multiple batteries are needed to back up your whole home. And I will talk a bit more about sizing your system in a few slides to clarify what this means. So this is an example of a whole home backup. As you can see, there's multiple batteries in one home providing power to theoretically the whole home. So sizing your storage depends on what you want to power and for how long. With a given amount of storage, you can either power more things for less time or fewer things for more time. So you could choose to power a refrigerator, several lights, and a laptop for a couple of days. Or with the same battery, you could, let's say, get rid of the computer, which will allow you to power the lights and refrigerator for longer. Or if you added a space heater, which has very high energy use, your period of autonomy would reduce significantly, possibly just to a couple of hours. Adding additional batteries can increase the amount of power, amount you can power and for how long you can power it, but it also increases the total system price because you are purchasing more batteries. Solar will allow you to recharge your batteries during the day. However, a typical residential solar system is not big enough to recharge your batteries faster than you are likely to deplete them. So don't expect an infinite period of autonomy, even with a whole home system backup. Once you understand your needs with system sizing, your contractor can work with you to properly size your system. So once you know what you want to power, your contractor can help you choose the size of batteries that you need to power that. You might also find that you are constrained by budget, available space for solar, or your existing electrical system. So touching more on your electrical system, typically the things you want to power will need to be separated from the rest of the circuits in your home and routed to a new breaker box. And this is called the essential loads panel. When choosing your essential loads, you want to focus on which breakers in your current panel you would like to move to a new essential loads panel. This can be it can be very difficult and expensive to divide circuits, so we recommend working with what you already have. So to make this more clear, if you already have a circuit in your home that powers your refrigerator, a string of lights in your kitchen, and 3 outlets in your kitchen, you could decide to move that entire circuit into your essential loads panel and have it be backed up by your battery system. Now that we understand the technology and have learned how to assess our solar potential, let's go over the money and see how to finance it. So in general, zooming out, costs have fallen significantly over the past decade for solar panels. We also have 3 great incentives to take advantage of here in Oregon. The first is a federal investment tax credit. Second is a statewide solar plus storage rebate. And the third are incentives through Energy Trust of Oregon. So the federal investment tax credit, the Inflation Reduction Act just expanded it to a 30% tax credit available for the next 10 years, which is really great. And this is a dollar per dollar incentive. So 30% of the net cost of the solar system will be returned to you through your tax filings. And another big change through the Inflation Reduction Act is that you don't need to have tax liability now to receive this tax credit. The state of Oregon Solar Plus Storage Rebate offers up to $5,000 for a solar system, depending on your system size and income eligibility. And I'll go over a bit more of the details of this in a few slides. Finally, the Energy Trust of Oregon provides a cash incentive for solar that is available within Energy Trust territory. So your utility must be either PGE or Pacific Power. And you must also install with a Energy Trust Trade Ally contractor. And I'll talk more about this in the future as well. So shall I go back to this slide? So the Energy Trust of Oregon standard incentive is $500 or $600, depending on if you're PGE or Pacific Power. If you are income eligible, according to Energy Trust of Oregon's income eligibility threshold, instead of getting the $500 or $600 incentive, you can qualify for the Solar Within Reach. So it's an either or situation. The Solar Within Reach is a really great program they have for low and moderate income households. If you are a Pacific Power customer, you can receive $1 per watt up to $6,000. And or if you're a Pacific Power customer, you can receive $1 per watt up to $6,000. And if you're a PGE customer, you can receive $1.20 per watt up to $7,200. Jumping back to the Oregon Department of Energy statewide solar plus storage rebate for lower moderate income homeowners. And I will note that this lower moderate income threshold is different from Energy Trust lower moderate income threshold. So you want to check if you qualify for both of them. So for the statewide solar plus storage rebate, lower moderate income homeowners receive $1.8 per watt of installed capacity up to 60% of the net cost or $5,000, whichever is less. If you are not lower moderate income, but you are eligible for an electric utility incentive, such as the Energy Trust incentives, you will receive 20 cents per watt up to 40% of the net cost or $5,000, whichever is less. And if you are not lower moderate income and are also not eligible for a electric utility incentive, you'll receive 50 cents per watt up to 40% of the net cost or $5,000, whichever is less. So that was a lot of numbers to throw at you. I'm going to throw a few more at you, but this will hopefully bring it all together and make all the numbers make sense. So this is a sample budget for Portland General, 2 customers from Portland General Electric. On the left, we have a customer that is not lower moderate income, and on the right, we have a customer that is lower moderate income. Both are installing a 6 kilowatt system. And we've put both of the total eligible project costs at $20,000. Now, this comes with a huge grain of salt because project costs are extremely difficult to predict. They depend on a lot of specific circumstances, such as if you need a re-roof, if you need more structural support for your roof, if you have a complex or simple roof, if you're ground mounting or roof mounting, what type of inverter, what type of panels, all these things factor into the total project cost. But for this example, we're going to start with a project cost of $20,000. Then we're going to apply the Energy Trust incentive. So for the non-income qualified household, they'll receive $500, and for the income qualified household, they'll receive $7,200. Then we'll apply the Oregon Department of Energy rebate, and that's $1,200 for the non-income qualified household and $5,000 for the income qualified household. And then we apply the 30% federal tax credit. And that puts us at a final cost to customer before energy savings for the non-income qualified household at about $13,000, and for the income qualified at about $5,500. Now, comparing this to 2 Pacific Power customers, it's very similar. The key difference is the Energy Trust incentive. So for the non-income qualified household, they'll receive $600, and for the income qualified household, they receive $6,000. So we get a final cost to customer before energy savings for the non-income qualified household, again at around $13,000, so fairly similar, just $100 less. And then for the income qualified household, it's at $6,300. So if you're ready to consider your options, you might be wondering where to get started on this process. The great news is that Energy Trust of Oregon has a list of trade ally solar contractors that are rigorously qualified by Energy Trust, are familiar with all of Energy Trust design and installation requirements. And these also, using these trade ally contractors, give you access to Energy Trust incentives. On Energy Trust of Oregon's website, you can request a custom analysis and bid for free from 3 of these trade ally contractors. All you have to do is fill out this simple form. This is really easy to use and a great way to get started. You fill out the form and 3 contractors will contact you for free with an analysis and bid. So I'm going to drop the same links in the chat one more time. And in these links, you will find the link to this tool. Once you've selected your installer and signed your contract, the installation process begins. This is a turnkey service, so once you sign, your contractor handles the rest of the project. The installation itself typically takes just 1 or 2 days for a residential project. However, before installation begins, your contractor must obtain permits, apply for the Energy Trust incentive, and apply for net metering with the utility. There may also be a waiting period before your contractor can get you onto their construction calendar, depending on how busy they are. So this whole process could take a few months. After the system is installed, your contractor will manage all inspections and the grid interconnection, and this can take an additional couple of weeks. And then once your utility approves your interconnection, your system will start producing clean electricity, and you're good to go. That wraps up the presentation portion of this webinar. I don't see any questions in the Q&A box right now, but I will hang out here. If you all want to put your questions in there, I'm happy to answer as many as I can. We don't have Zach with us today. He's able to answer more questions than I am usually, but I will do my best today. I also am going to launch one more poll to get your reflections and feedback on our survey today, or on our webinar today. And this helps us improve our content and make sure it's helping you all. Great, thank you all for filling out that final poll. Again, if you have any questions, I really encourage you to put them in the chat. I like answering them, and we want to answer as many questions as we can so you all feel confident and ready to get started on this process if that's what is interesting to you all. Okay, what are the typical lead times for installation these days? So that's a great question. I know that the lead times have been quite high recently due to increased demand and lack of supply. And so I think it can depend on the time that you contact a contractor and how overbooked that contractor is during that time. That's a fairly vague answer because it does change quite a bit. So I think talking to a solar contractor, filling out that tool, and talking to some contractors and asking what their lead times are is your best bet moving forward. I'm gonna hang out until 6:35 to see if you all have any other questions. Throwing my email up on the screen, so if you think of anything afterwards, feel free to email me, and I will try to respond quickly with an answer to your question. And if you all don't have any questions, we'd just like to thank you for coming. We appreciate everyone who's eager to learn about solar. All right, we have another question. Does that link include contractors from the South Valley? So that link is for contractors through Energy Trust, and Energy Trust serves, I'll pull up the slide again. serves customers from PGE, Pacific Power, Northwest Natural, Cascade Natural Gas, and Avista. And so the solar contractors are going to be ones that serve those areas as well. So I don't know the map of the utilities and where it lines up with South Valley off the top of my head, but that is something to consider. Um, Dustin says that he's in Eugene. You have eWeb down there. How would you find a contractor in your area? That's a great question. I would say to Google it and poke around. I unfortunately don't have a lot of knowledge of contractors that aren't trade ally contractors. And so I would ask if maybe eWeb has some recommendations or contacts with contractors, or just poking around the internet and seeing what you can find down there. Sorry, that's not the most helpful answer, but yeah, that's something we haven't looked into that much. All right, I'm going to wrap up this webinar. Thank you all for joining and for your questions, and have a great night.